Okay, so today we're going to talk about different types of convergence. All right? So, for absolute convergence, all right, so if the sum of the absolute values converge then the sum of A sub n without the absolute values is absolutely convergent. But it's written above, so you get the idea. Okay, so that's absolute convergence. All right. There's another type of convergence as well. This is known as conditional convergence. All right, so now for conditional convergence, this says if the sum of the absolute values is divergent, but the sum of the series itself, it is convergent, right? Then the sum of A sub n is conditionally convergent. Okay. There are other types of convergence as well. All right, so how do we actually go about the process of determining if something is absolutely convergent or conditionally convergent? Well, I'll give everybody a second to copy that down. What you first have to do is, I'm going to write this down in a second, is you have to check the absolute values. Okay, now if you check the absolute values of that series and it converges, you just stop. You're like, that's absolutely convergent, I'm done. Okay? So, what you have to do to check for these different types of convergence right? So the first step is to first check for absolute convergence. Use some abbreviations. Okay, but if the sum of the absolute values of A sub n is divergent, then what you're going to do is then check for conditional convergence. And we're going to have another test for this. okay? And this is going to be, you're going to check for conditional convergence using the alternating series test. Okay? And so now we need to discuss what the alternating series test actually is. So, if you're, so, what is the alternating series test? We'll give this as a definition and then we'll go on to some actual examples of this. All right, so, what is the alternating series test? Okay, so the alternating series test says that if you're given some alternating series, the sum, I'm going to leave indices off on this one, of -1 to the n, a sub n, okay? If you're given an alternating series, if you can show that 1, it's decreasing, eventually, okay? And the limit as n tends towards infinity of a sub n equals 0, then the sum of -1 to the n a sub n converges. Okay, now there's something that I need to point out at this point. The alternating series test does not distinguish between absolute and conditional convergence, okay? The alternating series test says just if you have an alternating series and it's decreasing and the limit goes to 0, then it is convergent, okay? It does not distinguish between absolute and conditional convergence. Okay? So to actually do this problem, what you have to do is first you have to check for that absolute convergence. Put absolute values on that thing. And if it's absolutely convergent, you're just like, well, all right, that thing, if I did the absolute values and it's convergent, then stop. Just say absolutely convergent, okay? But if you take the absolute values and show that it's divergent, then you have to use the alternating series test to actually prove conditional convergence. So conditional convergence actually has 2 parts to it. First, you have to prove that it is not absolutely convergent. And then you have to say, all right, now I'm going to use the alternating series test after I've proven that it's not absolutely convergent. And if I can show with the alternating series test that it is actually convergent, that's when I can actually make the statement that this is conditionally convergent, okay?